For week 7, I had problem 43, and in problem 43, the ascenders are cable cars built on stilts to keep the passengers level. One car ascends as the other descends. Cars use a 2-cable arrangement to compensate for friction, one cable passing around a large pulley that connects the cars. The second is pulled by a small motor. Suppose the mass of each car with passengers is 1,500 kilograms. The coefficient of rolling friction is 0.020, and the cars move at a constant speed. And so for part A, we are going to solve for the tension in the connecting cable, and then in part B, we're going to solve for the tension in the cable connecting to the motor. And so before we begin, some important equations to note right here. These first two we will be using to resolve forces for the car moving in the downward direction, and then these two will be used to resolve forces for the upward direction, specifically these two for perpendicular forces and then these two for forces down the slope. And then we will also be using this friction equation right here. And so moving on to the figures, we have two figures, one for the car moving in the upward direction and one moving in the downward direction. The car moving in the upward direction experiences tension in the cable joining the cars, as well as tension in the cable connecting the motor. So this is what we will be solving for in part B. And then it also experiences just normal force, gravitational force, and then friction. The car moving downward does not experience the tension in the cable connecting to the motor, but it does experiences the rest of the tensions, the rest of the forces with tension, friction, gravity, and then normal force. And so moving on to the solution for part A, we're going to be solving for the tension in the connecting cable. So that is just this regular T right here. And so to do that, as I said before, we will be using these two equations as well as the friction equation. And so to start, we need to resolve forces perpendicular to the slope. And so to do that, we are going to rewrite this equation to get our d on its own, and then plug that into our friction formula. And when we do that, we get this new friction formula. And then kind of taking the same steps, we're going to plug this new friction value, here into this equation into this equation right here. And when we do that, we have this newly written equation that we can then rewrite to solve for the tension, or to get tension on its own. And when we do that, we get tension equals mass times gravity times sine of theta minus the rolling friction of cosine theta times cosine theta. And so here we plug in everything that we know and everything that we are given, and we solve for the tension on the connecting cable, which is 8,190.74 newtons. And so moving on to part B, we'll be using these equations for the upward cable, and we will be solving for Tm, the tension in the cable connecting the car to the motor. And so to begin, we'll follow many of the same steps in part A, starting with rearranging this equation and then plugging this part of the equation here into the friction equation for Ra. And when we do that, we get it rewritten as it is here. And then again, we will plug in our new Fu value force of friction in the upward direction. This should be U right here, but I mistakenly wrote it as F. So we will plug this value right here for this value in this equation. And when we do that, we get this newly written equation, and then we can solve to isolate this tension, or the Tm tension of the cable in the car connecting the motor, or the cable connecting the car to the motor. And when we do that, we get this equation right here. And when we plug in everything we know, we solve and get 481.7 newtons.